Hello everyone, these are the solutions to the Check Your Understanding for Lesson 72. Before we get into this, I would like to mention on these three free response problems that there is nothing in my solutions that you can leave out and get full credit on your free response. So as you look through my solutions and compare them to your solutions, if you're missing something, that's not going to earn you full credit. Some of you guys, I think, get the impression that you don't have to show all this to solve the problem, and so then you do your can you do, and you leave a lot out. You don't organize your problem like I do in class, and you don't check everything and write everything that I write in class. And honestly, family, if I didn't have to write all this stuff out, why would I do it? Like, really think about that, because I know for some of you guys that this isn't your favorite thing. Like, you don't want to have to write all this out when it can be written more succinctly, or you could do shortcuts. So just know that I know that, and I sometimes feel that way too, but I know that if I want to get full credit, I have to write all the things out. So as you compare your answer to my answer, hopefully you're actually listening to me or reading the subtitles and you're hearing, there is not a single thing on this response that you can leave off and get full credit on your free response questions. Okay, I'm not really going to go through this too thoroughly, because I've been trying to build time into each class period where I can come around and answer any questions for you. So basically, I'm just going to let you compare your answer to mine. You don't have to organize it the same way that I do, but you need to have every single thing that I have. If you're worried that your definition for P is not correct, or if you're worried that something that you've written, it's different than mine, so would it be acceptable? Just email me, take a picture of it and email me and say, hey, would I get full credit for this? Or as I'm coming around to check with you during class time, just show me. When I say, hey, did you have any questions? Say, yes, I had a question on this problem. Would I get full credit for this? So this is my state and plan for the parking situation. One thing to note is that if the change was effective, more people would be satisfied with the parking. So if more people were satisfied, then it would be greater than 30%. Make sure that after you check large counts, that you actually write so we can do normal calculations. Some of you guys just write the calculation and that's it. You want to indicate that you know why you're checking these conditions. So especially on this last one, why are you checking this weird n times p and n times 1 minus p? Well, so we can do normal calculations. You can see the calculation for my z, my curve. A sample value of 41.5% is 1.32 standard deviations above the claimed value. The chance that I would get the sample that I got if the null was true is 9% in this case. So we failed to reject. We do not have convincing evidence that the change was effective. Next up is the we want to be rich problem. So this is my state and plan. This is a two-tailed test, so this is my do and conclude. The conclude on this one was very long, I felt like. And then lastly, I mentioned in one of the class periods that this is arguably one of the most important problems that we do in this entire class. I would say it's easily top 5 most important problems to understand. So the advice that I gave a lot of you guys was solve the problem out. Completely ignore their solution. Solve the problem on your own, and then go back through and highlight the things that they got wrong. So I'm going to go through this one a little bit more in depth, and I would encourage you to stick with me and verify that you identified all of the errors. First error is in the alternative. It's basically all wrong. So it shouldn't be hat, it should be P, and these numbers should be the same. The only thing that changes between your null and your alternative is the symbol. The parameter stays the same, the value stays the same, the symbol changes. The 0.75, the claimed value, should be the value used for the alternative. So the alternative should have been P greater than 0.75. Where P is the true mean proportion, you don't need the word mean. That doesn't make sense. So just the true proportion of middle school students. And then this was kind of a hard one to catch, but that engage in bullying behavior. The correct thing to write there is bullying behavior. Make sure that you are, if you didn't catch these, that you're adding them in and you're correcting them, because up here, notice it says correct the mistakes. So you need to correct them as well as identify them. The random condition was checked correctly, but they did not check the 10% condition. So down here, I have checked the 10% condition. And then for the large counts condition, they use the wrong formula. So the only place that you use 797 is down here in your Z calculation. So this really should have been 538 times 75, 538 times 25. The calculation for your Z value was all wrong, like totes wrong. So that correct calculation is down here. One note, if you plugged in the actual fraction, so if you plugged in 445 out of 538 instead of 0.797, then you got a Z critical of 2.59. So if you estimated it as 797, your Z critical is 256. But if you used the actual proportion, 445 divided by 538, because this is more precise, your Z score is a little bit bigger. Then our last thing is our conclusion, and there are some really important errors in here. So the probability that the null hypothesis is true, no way. We are never, ever, 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 ever checking or showing or proving or testing if the null is true. What we're doing is testing if there's evidence against the null. So we never mention anything about the null being true aside from when you check large counts. In fact, now that I'm saying that up here, I probably really should have put assuming HO is true. Then n times p and n times 1 minus p. So assuming the null is true, large counts is met. I'm going to see if I put that in any of our practice problems. Yeah, I did. So, no, never mention anything about the null being true except for when you're doing your calculation up here. This proves that more than 3/4 engage in bullying behavior. No way. We are not proving anything. Our test does not prove things. It only tells us if we have evidence against. So we are very, very careful when we use the word proves in stats. That is a super strong statement to make in statistics. The correct p-value is 0.52. If this was your z-score, then your probability was 0.0048. And then lastly, here's my conclusion. Since the p-value is less than the default alpha, we reject the null. We have convincing evidence that more than 3/4 of middle school students engage in bullying behavior. So, please, 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 on these 3 problems, if there's any confusion, ask me. I'm so happy to help you. I want you to be successful, so don't even let the little things go. Really ask me and get things cleared up, because this is one of the most important things we learn all year. So, any questions? Get them cleared up. We're going to practice this a lot, so you'll have a lot more exposure, but don't go too long with your misunderstandings if you have any. Okay, that's it. Love you guys.